So today I want to share a little real life experience of rewriting a product 4 different times. My name is Leon Hu, co-founder and a CTO at Doctable. There's always a short answer to a trivial question. Maybe it's an answer I tell my non-engineering wife before bedtime, or tell my non-engineer friends over beer. Maybe a little bit out of the humility or self-assuring excuses, but certainly not an answer I'd use in an investor meeting. So I suppose any of these answers will get me fired. Now, a little background about what Doctable do. We deal with software that's written in the early 2000s. We extract as much data as possible for automations. So healthcare providers like your average dentist don't have to play phone tags with their patients to remind about their appointments. Headquartered in San Diego, with customers spanning all 50 states. Our customers love us, but sometimes they forgot, about Doctable exists. You know why? Because our automation solution works in the background seamlessly, from confirming and reminding patients about their upcoming appointments, checking in patients when they arrive in the parking lot. So we have a small team of 6 person with 2 to 3 developers. Everything was built in house with love and extreme care. Now let's jump into a little trivial product that we wrote it 4 times. So mind you, this is the systems that we deal with. When you walk into a dentist, they do your patient intake information, and to be able to store it in their databases back in the server room that's collecting dust. But we don't write these software, but we write software to be able to automate some of these workflows, such as reminding patients about their upcoming appointments. So our tech stack is, kind of like a really average. I wouldn't say it's more like a cutting edge, but we use Ruby on Rails, React JS, Sidekick, WebSockets, things like this. But I want to jump into this trivial product that's we've been dealing with. So I'm sure all of you guys here have received a text messages before reminding about your upcoming appointment. So we have a simple message saying, "Hi Sarah, just friendly reminder you have an appointment at 3 p.m. tomorrow. Sincerely, Smile Dental." Um, so if you have appointment, you get appointment reminder 1 day before your appointment. Here's about, I would say, 15 lines of code. Everyone can understand. Uh, you know, you have appointment belongs to a patient, which belongs to a practice. When it's 1 day before the appointment, call appointment.remind. Simple as that. Would almost work out of the box if you just hook up with a SMS vendor such as Twilio. So now this is about to get complicated from 0 to 100, based on customer requests and issues. Here's some of the things we've been dealing with in the past, 3, 4 years. So, for example, customers want different schedule, intervals. So, what if a patient want to be reminded multiple times before their appointment? What if a family of patients, such as minors, share the same phone number with their guarantors? So, do they get spammed by text messages? What if a patient has multiple appointments in a day? They don't want to get spammed either. What if an appointment requires special instruction to be embedded in their reminder messages? What if a patient cancels their appointment right before their appointment? And also a good problem to have. What if your product catches traction and it need to be scaled quickly? So here's the MVP we just talked about. Of course, uh, real life production code was more than 15 lines of code, but it was probably a week worth of work. We pushed to production, high five each other, crossing arms, waiting for all the sales to come in through, and just counting all the deals. But the truth is that the calm lasts about 5 days. So we quickly found out our families sharing the phone numbers like to get their teeth, like to get their teeth worked on together. Our first data modeling was naive enough that we assume patients get their own phone number and that they don't mind receiving multiple messages a day. Then turned out we quickly found out an appointment to patient doesn't quite equate an appointment to a practice. So you actually have to separate appointment with hygienist and the doctor. So those are distinct appointment objects in their database. So we need to start grouping appointments to reflect employment reminder text messages. So we did a bunch of data remodeling and the data migrations. So who knew a time-based messaging system involving 30 different type of scheduling software could be this hard? So that was our first rewrite. Much better experience, single message, patients thinking, hey, that's a pretty clean solution. So, uh, however, our second rewrite was under even more pressure. Sales picked up in the right direction. Customers loved the user friendliness and the accuracy of our reminder software. Just when we tried to start building a new product, knock knock, performance bottlenecks come to visit. So we had a bare minimum performance monitoring tools. On top of it, we were pulling of all future appointments needed of a reminder every 5 minutes. Our job server reached memory stress. Our database was working overtime, blocking other important read and write operations. So we're actually missing traffic. I mean, that was a big deal. So we thought sky was falling. It was definitely a wake up call. So after addressing a few immediate bottlenecks and scaled back some features, we bought ourselves a couple of weeks. So during which time we examined all possible approaches. We got Datadog working on our big screen TV on the alert dashboard. And then we had our, um, that's our, second rewrite. So but fast forward a year or so, when we think everything's great, we had our last rewrite. So the goal is to create a comprehensive reminder system. Not only will accommodate multiple reminder schedules, but also adjust reminder messages based on all attributes of appointment. So on top of everything, so it needs to be fast and accurate. Dealing with about 500,000 patient messages a day, a pretty tall task. So this time we took time to explore options, architecture, data modeling, migration to execute and migrate customers in batches, additional toolings, more specs, multiple tech debt iterations to prepare and then make room for performance. So you name it. So we eventually settle on using event-driven architecture. Event-driven architecture is a design pattern that build around the production, detection, and reaction to events that take place in time. Event-driven architecture enables minimal coupling, which makes a good option for modern distributed application architectures. Event-driven architecture focuses on the generation and handling of event notifications. So it's perfect for our use case of knowing appointment happened based on the characteristics of the appointment and other business rules. The event manager massages these information into a single processable entity ready to be consumed by the event consumer. Since the services are decoupled under an event-driven architecture, and the services typically perform only one task, so tracking down these bottlenecks from business bottlenecks to performance bottlenecks to a specific service, and scaling that service becomes really easy. This pattern achieves high performance through its asynchronous capabilities, the ability to perform decoupled, parallel asynchronous operations, always the cost of the pulling information. So now that's enough bragging, but I want to share a few lessons we've learned and a few tools we use along the way. So I think these are probably the most valuable information we can provide, as a company, as Ruby shop in the community. So, uh, with many time-based use cases, test-driven development really works. But can you visualize all the complex use case in our spec? Can be challenging. So we explored a few options and chose Finis, a wiki-based testing tool that our QA tester can easily create test cases. So you're not you're not about to use a single language to create a successful project. So don't let language be the barriers to become successful project. Uh, Pay for the APM software. So that's is one of the very important lessons we learned. Try to save every penny at the beginning, but I think when we get to performance bottleneck, I think the economy really scales. So they're actually worth every penny. So if you get to a point where a simple log telling just wouldn't give you any clue about what went wrong, so see this related logs button right here. So it save our lives numerous times, before things really go bad. And also, are you paying attention to your memory usage? So we didn't do so, but we paid the price. So Ruby is not known for being a language that's low on memory use. Many Rails applications suffer from up to a gigabyte of memory used per process. So that's almost approaching Java levels. However, Sidekick, the popular Ruby background job processor, has processes which can get just as large or even larger. Uh, Memory fractation causes logarithm growth in memory. It looks like long curve approaching some unseen limit. Since we started pay attention to memory growth, we simply tried a different allocator. So JE Malloc also implements per thread arenas, but also their design seems to avoid the fragmentation issues present in Malloc. So we have seen memory contained and expected since. So and then we can sleep better. Also, the other lesson we're learning is that pay attention to your top 10 poor performing queries. Please make it a habit. Pencil it in on your calendar. Make it an item to review with your team during retrospectives every iteration. Leverage free tools such as the PG Hero. So it's a free performance dashboard that works well with your Postgres. It takes minimal setup, include the gem, and then it's ready to go. Monitor your database space and adjust volume to increase your IOPS accordingly. Talking about jobs, I think the important thing here is to spread out non-critical background jobs. This not only reduces concentrated load on the database, but also is friendly to your server's memory consumption. Spreading the workload across multiple workers allow the garbage collector to do a better job, freeing up some unused allocated space on the memory heap. So here's a little simple module we wrote to be able to scatter all the jobs within a certain time frame you define. So it came in really handy for us. There are also many reasons to pay attention to your outbound API requests. If you can't spread out your background jobs making outbound API requests, you may be able to optimize some jobs using parallel requests. So we found out that Typeforce's Hydra feature a very suitable tool for us to leverage. So increasing some of our jobs performance, by multiple folds. Typeforce is also great because it wraps a low-level wrapper around libcurl. Having libcurl as a base adapter gets us HTTP 1.1 keep alive support, so which drastically improves performance by keeping TCP connection open for multiple HTTP requests and responses. Finally, consciously define your timeouts for external API calls. You never know when third-party APIs are poor performing or timing out. That can consume all your resources, maybe eventually blocking all your traffic. So, and we don't want that. Talking about database, we have one more tip on the database. So if you have a slave replica database, please leverage it for read-only endpoints. So your application lags should usually be around milliseconds. So reading from your replica is just as good as the master database. So here's a little wrapper module we wrote to be including all of our read endpoints that's in the relevant controllers. So it's been working like a charm. So the downside is, of course, that you have to monitor additional database, but layer external monitor tools, APMs, Datadogs, and such tools to be able to monitor these processes. Additionally, some other lessons we'll learn is that try to reduce the stress from other part of the platform, especially using pushing instead of pulling when possible. Uh, the tools right here where you apply these using any cable. So make it possible to write a high performant real-time application using Ruby as a language for implementing a business logic. This goal is achieved by moving low-level responsibility, that handling sockets, parsing frames, broadcasting data to WebSocket servers written in other languages. So we don't usually like microservices pattern, but we highly recommend moving low-level consuming responsibilities to somewhere else. Finally, so we have some conclusions of others' advices, the tips that we applied along the way. Not necessarily applying to everybody here, but just some of the techniques we've used along the way. Don't give up. Try different tools to look for performance clues. It takes hard work and groundwork, and it takes time from experts and non-experts, right? And the performance debt will always be there, and it's a real thing. It's a matter of how fast you need to scale and how fast you want to pay it off. And here are some of the tips we come across. We want to say that many developers don't realize that you aren't alone in this fight. Get buy-ins from and the support from your leadership team, from your business teams. Educate them. I think it's an equally important step towards a successful and a scalable product. That's all my time. Special thanks to all the talented individuals at Doctable worked on this project and the slides. So everybody on this team has to contribute a fair amount of time and energy to be able to come up with these solutions over the course of years and to be able to put together the slides. So kudos to you guys. Can do it. Where are you folks? Finally, PS, we're hiring and I have multiple engineering positions opening. Please check out doctable.com/careers. I'll be looking forward to hear from you.